So for number 7 on the review packet, dilate a line. Dilations in general will preserve slope. That's a key concept. So with preserving slope, what we end up getting is, if we dilate a line, we're going to get a parallel line. Same slope, parallel line. So what we do is, I would probably graph this line right here. So I'd start the y-intercept of -3 and go from there 1, 2, 3, 4, 5. And if I had a straight edge, I would graph that. Okay. Here's your center. One of the things I like to do with these is take a point, if I can find one that's on the line, either directly under or directly across, it's best to do that. I have a point that's 3 away from my center. What I'm going to do is I'm going to take that number, I'm going to multiply it by the scale factor. So if that's point A, let's say, point A is going to move now. Instead of 3 units from the center, it's going to be 6. So 1, 2, 3, 4, 5, 6. I'm going to go back, though, to the center. All right, that distance has to be 6. So that's going to be where A prime is. From there, all I've got to do is apply the same slope. Up 5 over 2. Up 5 over 2. Continue that, and what you're going to notice is we do get, in fact, a parallel line. It does have a different y-intercept, so the equation of the line is y equals 5/2. Now I had that anyway, the same slope, -6 was the y-intercept, is what it ended up being. Briefly explain or show how you arrived. Hopefully this does show work enough. So I will just explain them. Dilations preserve slope. So my line has a slope of 5/2, same as original. Point A, the y-intercept of original line was 3 units from the center. I call that the change in y. So multiply that by the scale factor. Of 2. So you get 6 units. So y-intercept is now -6. All right, good enough. That more than does it. So given that PQR, this symbol is similar. Okay, so given that PQR is similar to LMN, oh, this is pretty reasonable. Why are those angles congruent? Well, what we have to know about similar figures, I'm going to do a little more than we need, but similar figures have corresponding angles that are congruent. Okay, which is why angle Q is congruent to angle M. Okay. More so, similar figures also have corresponding sides that are proportional, but they only wanted us focusing on that. Okay, so that's what we'll do. All right, so we have a 5-foot girl casts a shadow of 8 feet. Okay, so this individual is 5 feet tall. Shadow lands on the ground of 8 feet. All right, let's assume the ground is the girl is are perpendicular. You don't have to complete this, but that's basically what's going to happen. All right, a tree is going to be a little taller. It looks like it's going to cast a shadow of 24. It's not going to be to scale. I don't know how tall this is, but this is a shadow of 24 feet. So what's the height? Corresponding, we'll put this on top the whole time, right? So 5 is to h as 8 is to 24. Okay, get the cross products equal. H is 120. Divide by 8. Probably 15. Yeah. So, okay. Tree height is 15 feet. Okay. Doing okay on time here. Okay, solutions. Interesting. Okay, so they went with 30 ounces of the entire solution. The solution is broken up into 3 parts, 3 water to every 2 salt. Okay. All right. And what's going to happen is, let's say we're to, I usually do this with a scale factor. Salt is all we want. Okay. We could call it, if we add these together, we could call the total is going to be 5 parts. So what we could do is say, yeah, we want 2 parts salt to every 5 parts for the solution. Okay? So what I'm saying is I'm putting the water and the salt together. For every 2 parts of salt, we're going to make 5 parts of solution. We want to know how many parts of salt. Ooh, wait a minute, that's tricky. How many parts of salt? I think they could get how many ounces, but I don't know. This is a little bit tricky. Let's see what happens here, because it's going to be 30 ounces. Okay. This is only going to get us the, looks like this is going to get us the ounces of salt. All right. Let's give this a shot here. So we've got, let's get rid of the units of measure. 5 times x equal to 2 times 30. Now what I get is, I get 12 ounces. But how many parts is that? Okay, I think we can go with this. So 12 ounces of salt. Okay, I'm gonna still assume that they mean how many ounces of salt. I could go with parts. I don't know, it's coming out when I do parts is 6, but there's no connection between parts and ounces. So I can't really, I don't know, I'm struggling with this one. It's either going to be that we want the parts of 6, but I think they want the ounces of salt. That's what I'm going to go with. I'm going to go with choice D. Okay, 12 ounces of salt, because again, there's no connection between parts and ounces. All right, let's see, solve for A and B. Okay, so this is one of those questions where we have parallel lines. So each of these parts, each of these corresponding parts in between, those are going to be proportional. So what I'm saying here is I can go with this being the top and this being the bottom, this side. Okay. So what's going to happen is between these parallels, 4 is to A as 8 is to 10. So stay on the, put this on the top at all times. Okay, equal sign, get the cross products. And divide by 8. So we get A is 5. Same thing with B. So we can go 6 is to B as 8 is to 10. Now this only works when we have these parallel sides. Okay, so we'll do cross product. 6 times 10 equals B times 8. Something doesn't look right there. Well, we're going to get a decimal, looks like. I think that's 7.5. So A is 5, B is 7.5. All right, that'll be all for this video session.